So you'll probably recognize these first three questions. What number times itself equals 36? We've already done this before in the last lesson. 6 times 6 is 36. 16 times 16 is 256. What number times itself equals 8? Well, this is called an irrational answer. It's this long decimal that goes on forever and ever. We learned in our last lesson to simplify it to 2 radical 2. Okay, because 8 can just be written as 4 times 2, and the square root of 4 is perfect, so it reduces. But at any rate, we've already done all that. The main point of today's lesson is this last question right here. What number times itself equals negative 81? Well, there's a dilemma here because we know 9 times 9 equals positive 81. But we also know that negative 9 times negative 9 equals positive 81. A negative times a negative is a positive. And so there's seemingly no way, you could try to do 9 times negative 9 equals negative 81, but then the two numbers aren't the same. They're not identical. Okay, so we have this dilemma here. How are we going to get this to work? Now I can pull up my calculator. I can try doing the square root of negative 81 in my calculator, and I get the dreaded domain error. Calculator can't even do it. All right, so I'm here to tell you today there is an answer to this question, but it's a number that was invented by mathematicians. It's called an imaginary number. The answer is 9i. 9i times 9i is equal to negative 81. So here's a breakdown of this invented imaginary number I. So the square root of 81 equals 9 because 9 times 9 is 81. So the square root of negative 81 is actually called 9i because 9i times 9i equals negative 81. Okay, here I occurs every time you take an even root, that'd be like a square root, a fourth root, or a sixth root, etc., of a negative number. So here we're trying to take the square root of a negative number. That's always going to result in an I. I is the only number in the world that gives a negative answer when multiplied by itself. So there's a rule that says I times I is equal to negative 1. I is the only number, I is this invented number that when you multiply it by itself, or you can say that when you square it, it comes out negative. And mathematicians kind of realized there was no other number in the world that had that property, that you could times it by itself and get a negative answer. And so mathematicians just invented this number I. So technically, when you do 9i times 9i, it technically comes out to 81i squared, but then I squared can always be simplified to negative 1, so it's really just 81 times negative 1. It's negative 81. So I is a trick way. It's a number that you can multiply by itself to get a negative answer. That's why it was invented. Now you can also define I as, you can also call I the square root of negative 1. That's one way you can define it. And as we already said on the last screen, I squared is equal to negative 1. I times itself equals negative 1. Well, there's some interesting properties if you kind of keep continuing with this process. So what that means is that I to the third is actually negative I, and here's why. I to the third can be rewritten as I squared times I to the first. And remember, anytime you have an I squared, that can be simplified to negative 1. So I to the third, you can say that it's equal to negative 1. But then, this is kind of bizarre too. I to the fourth actually becomes a positive 1. And here's why. I to the fourth can actually be written as I squared times I squared. And remember, anytime you have an I squared, that can be written as a negative 1, and negative 1 times negative 1 equals positive 1. But then here's what's even crazier. This kind of gets more and more bizarre as we go. I actually starts to follow this pattern. If you take I to the fifth, it turns back into a normal I. I to the 6th is negative 1, I to the 7th is negative I to the 8th is positive 1, and this pattern just continues kind of in a cyclical fashion. So I'm sure many of your heads are kind of spinning right now. Mr. Klein, what is this I? Why did you bring an I into math class? So let's try to make this as practical as we possibly can. I know I is a bizarre thing, but let's try to get some kind of concrete examples of this. So anytime you try to take the square root of a negative number, remember your calculator is not going to help you. It's going to give you an error. But anytime the negative sign is inside the square root sign, here's what we're going to do. We're going to take the square root of positive 144, which is 12, but then because of this negative sign, we're going to stick an I onto the end of my answer. The square root of negative 144 is 12I. Now, here we kind of have a negative inside and outside. Here we already determined the square root of negative 144 is 12I. Here, this negative sign in front of it would actually make it a negative 12I. So yes, you can have, imaginary numbers can be positive or negative. Okay. And then in number 3, what should we do if we have a kind of irrational imaginary number? The square root of negative 48. First thing I'm going to do, here's one way to kind of think of it. You can always say a negative inside of a square root can always be kind of pulled out as an I. Okay, so we could write this as radical 48I. And then we're just going to break down our 48 like we did like we did in our last lesson. 48 is just 16 times 3. So the square root of 16 reduces perfectly. It becomes a 4. The radical 3 does not reduce. It stays a 3. But then don't forget about this I that we have here. So typically an I is written at the end of your number. But the one exception is if you have a radical. If you have a radical sign, this is the one case you actually write the I in front of the radical sign. This is most commonly written as 4I radical 3. Now technically, if you wrote your answer like this with the I at the end, it would be acceptable, but it's just not the kind of, it's not really the preferred way. Mathematicians prefer you put the I in front of the radical sign like this. Okay. Now, what happens if we ever try to multiply two imaginary numbers together? So we know the square root of negative 25, that would be 5I, times the square root of negative 36, that would be a 6I. What happens when you take an imaginary times an imaginary? Well, we're going to treat the I just like we would a variable, okay? If we had like 5x times 6x, hopefully you remember from earlier classes, that would simplify to 30x squared. You would do the 5 times 6 is 30, but then x times x is written as x squared. We're going to do kind of the same thing here. This would become 30I squared. But then remember our definition. Anytime you have an I squared, it can be rewritten as negative 1. So final answer, negative 30. And as a matter of fact, this happens anytime. Anytime you multiply an imaginary times an imaginary, the answer comes out to a real number. It's going to be negative, but it's going to be a real number. Okay. Scrolling down our examples here. What happens if we try to add two imaginary numbers? What if we take 5I plus 6I? Well, again, I has kind of the same properties as a variable would. Remember, if you try to take 5x plus 6x, you would get an 11x. It's going to be very similar with this. 5I plus 6I becomes 11I. Yes, you can add two imaginary numbers together, and the answer is imaginary. Now, number 6, so here the negative sign is outside of my radical sign. So this is not going to be imaginary. This is just going to be negative 5. But here my negative sign is inside the radical sign. It's going to become a 6I. So the question with number 6 is, can you add a normal real number with an imaginary number? And the answer is no, you cannot. Real numbers and imaginary numbers cannot be added together. This actually has a name. This is called a complex number. A complex number is anytime you have a real number like negative 5 and you add it to an imaginary number. like 6i. And you just have to leave them written like this. You cannot combine those together. Now what about multiplication? What if we try to do a negative 5 times a 6i? Can a real number be multiplied by an imaginary number? You betcha. It'd just become a negative 30i. We would just do the negative 5 times 6 is negative 30, and then keep the I. And then you can get into some bizarre situations here. This would be 2i times 3i times 4i. Well, 2 times 3 times 4 is 24. And then I times I times I is I to the third. Here's a case where I kind of want to reference back to my little chart here. I to the third simplifies to simply negative I, or negative 1i if you'd rather. So this becomes 24 times negative I, or negative 1i. It'd be negative 24i. And imaginary times an imaginary times an imaginary actually stays an imaginary. All right, and then save the hardest example for last. Can you FOIL two complex numbers? So this is called a complex number. You have a real 5 plus an imaginary 3. A real 5 plus an imaginary 3. And yes, you can FOIL two complex numbers. We would do it just like the FOIL method. 5 times 5 is 25. 5 times 3i is 15i. 3i times 5 is also 15i. And then 3i times 3i is 9i squared. Now, remember what happens with an I squared. Anytime you get an I squared, that can be rewritten as a negative 1. So this becomes 9 times negative 1, which is just negative 9. And then I'm going to combine all my like terms together. 25 plus negative 9 is 16. 15i plus 15i is 30i. Well, here's something kind of interesting. When you FOIL a complex number times a complex number, you get another complex number. So I do want to point out here, when you get to the last couple questions on your homework, a lot of these, the last, I believe, 4 questions are going to be FOIL method. Okay, you're going to be doing the example I just showed you. Here's question 14. We would do 2 times 4, 2 times negative 5i, 6i times 4, and 6i times negative 5i, that'd be negative 30i squared. And what's going to happen every time is we're going to be left with this I squared. Anytime you FOIL two complex numbers, this last term is you're going to be left with an I squared. It's going to turn this minus 30i squared. Remember, the I squared can be replaced with a negative 1. And negative 30 times negative 1 is positive 30. We can take the 8 plus the 30 is 38. And the negative 10i plus the 24i is positive 14i. So the answer there would be A. And then here, if you ever have like a 3 plus 2i squared, this actually has to be FOILed. We would write this out as 3 plus 2i times 3 plus 2i, and we're going to do the same thing. We're going to do the FOIL method to get that final answer. Okay. So hey, best of luck on this assignment. Let me know if you have any questions. Bye.